Welcome back to my YouTube channel. If you're not a subscriber, subscribe right now. So we're going to be going over question 4, and if you have got any other questions, you can send them 09789595795. So the question says a 0.500 kg cut connected to a light spring for which the force constant is 20.0 Newton meters oscillates on a frictionless horizontal air track. Calculate the maximum speed of the cut if the amplitude of motion is 3.00 centimeters. So we can collect our data first. Our data, so mass is equal to 0.500 kg, and then the spring constant K is simply equal to 20.0 Newton meters, and then the amplitude A is 0.03 meters. That's 3 centimeters. So we have got the free body diagram. This is a free body diagram. So I've got the spring. It's holding on to the cut. The cut, which is 0.5 kg. The spring K here is equal to 20.0 Newton meters. What else? We have got the amplitude. So if this is 0, the amplitude here is 0.03 meters. So now, the first question, it says calculate the maximum speed of the cut if the amplitude of motion is 3 centimeters. So now in the other question, if you check them out, we deduce that we know velocity is equal to negative a w sine wt. So now the maximum velocity will occur when this is actually negative 1, because this has got the range from 1 to negative 1. So v is just simply equal to a w. You can remove the negative because the negative just shows the sign and not typically the magnitude. Or if you put negative 1 here, you have a positive there. Then omega is just equal to k over m. So now we've got our k, we've got our m, and we've got our n. So now we can plug them in. So v is equal to the amplitude is 0.03, then k is 20, and the mass is 0.5. So now let's find our V max. This is the V max. This one is going to be equal to 20 divided by 0.5, 40, the square root of this, multiplied with 0.0. So the answer is 0.1897. You can just round it off to 0.9 meters per second. So now, the B part is telling us to calculate the velocity of the cut when the position is 2 centimeters. So now, in B, we have got the formula. So the formula is B is equal to V max, the square root of 1 minus x squared over a squared. So there's a video that I made on how to derive all this, but if you can manage to master this formula, it's alright. And sometimes this formula is even given in the formula sheet in the exam. So now our Vmax is 0.19. The square root of 1 minus x is 2 centimeters, which is 0.02 divided by 0.03 squared, which is our x. So now our V is going to be 0.02 squared divided by 0.03 squared. Then 1 minus, what is it? Let me start that again. 0.02 squared divided by 0.03 squared. 1 minus the answer 0.02 squared divided by 0.02 squared. 1 minus 1 minus the answer 1 minus 0.02 squared divided by 0.03 squared, and then square root of the answer times 0.19. This is giving us 0.1416 meters per second, which is the velocity at that point. Then when we go to see, it says compute the kinetic energies, the kinetic and potential energies of the system when the position of the cut is 2 centimeters. So now at this position, we have to find the potential and the kinetic energy. So now the first is the kinetic energy. So Ke is going to be equal to 1 over 2 mv squared. So Ke is going to be equal to 1 over 2. The mass was given as 0.5. Then the velocity that we found, that's the velocity at 2. So we're at 2 centimeters. We're at 2 centimeters. So the velocity is 0.1416 squared. So now this is going to be equal to 0.5, which is 1 over 2, times 0.5 gives us 0.25 times 0.1416 squared. The answer is giving us 0.005. So the kinetic energy at that point is 0.005 joules. Then the potential energy PE is going to be equal to 1 over 2 kx squared. So it's 1 over 2, k is 20, x is 2 centimeters, which is 0.02 squared. So now we have got that one there, 0.0, start from here, 0.5 times 20 times 0.02. The answer is 0.004. So the potential energy is equal to 0.004 joules. Now, you can end here, but on a rough piece of sheet, you can try to check if your answer is correct by analyzing that the total energy is equal to the potential energy plus the kinetic energy. But then you can also find the total energy by 1 over 2 k a squared, which is equal to 1 over 2, our k is 20, then our a is 0.03 squared. So then when you find this one, you're going to have 0.5 times 20 times 0.03 squared, 0.09 joules. So this is the total energy that we have in the system. Meaning at any point when you add this one and this one, it will give us this. And definitely when you add 0.004 times 0.005 or 0.009, which we've had using this one. So this this you shouldn't put this as part of the formula, but just to check if your working is correct, you can do this so that you confirm. So from me, it's bye bye. Remember to subscribe to the channel, and also we can interact by the number 07895797775, where you can send various questions and they can have them answered for you, just as I've done these ones. So bye bye.